Hi everyone, I'm Yanni. I'm a junior in computer science, and this is my video to be a 280 IA for the application. And today I'm going to be talking to you all about my favorite problem of 280, the deep copy problem. And I really liked this problem because when I first heard about it, I was like, well, that's stupid. C++ is the stupidest thing ever. But then after I saw the beautiful solution to this problem, I was convinced again that C++ is amazing. So we've learned that we can define our own abstract data types, ADTs, and we've learned that we can define ADT containers, where we take a container which is normally not very smart, like a normal array, and we can wrap it up nicely in a class and use dynamic memory and define different member functions in the class, like pushback and pop and size, to access elements in the array. And the really beautiful thing about this is we create an interface that a user can go and take advantage of without fully understanding all of the complexities going on in those functions. And another really great thing is that by defining all of these functions, we can now check the invariance of our container that we set and make sure that everything is working as it should be. We create a container which is reliable, easy to use, and so one thing you may not realize about dynamic arrays and dynamic memory ADTs is that we now know enough to get ourselves into some trouble, and what I'm talking about is the code behind it. What we have here is something called our int set, which is basically a dynamically allocated array. So I first create our int set v, that's fd, and then I push back these two elements. So in this case, v is equal to 5, and then we push back the number 100, 100, and this line, what we were doing is we create a new int set v2, and we set it equal to v. So this is the line where things fall apart, because this is what's happening here. Inside of v, we have some, v has some different members. It's a class and it has some members. So for instance, it may have a capacity, which is just an integer, and we have the number of elements in it, or the size, and that in this case would also be 2. And then we have data, and that is just an array. But we learned that arrays are really, under the hood, they're just pointers. So let's say that this array starts at address 1000 hexadecimal. Well, what C++ does in this case is it does something called a member-wise copy. And what that means is it's going to literally copy what's here over here. And what happens when you do that? You copy a 2 as the capacity, you copy 2 as the elements, which are fine because they're just integers. But when you copy the pointer, this v2 now is going to also share the pointer, and that's terrible because now we have this space of memory which contains our data, and data is pointing here. The data of v is pointing here. Then the data of v2 is also going to be pointing here. And this is a tremendous problem. And I will illustrate this in the next 2 lines. What happens is we change this data, and we change it to be 1 in 55. And what's going to happen now is, this marker is dying, 1 in 55. Okay. So now what happens is if we go and print v1 and v2, it's going to print the same thing because we're referring to the same place in memory, and that's a bad thing. This is probably one of the worst cases of undefined behavior you can have. Another terrible thing that could happen is if we now change the size of v1 or v2, we could trigger one of the members to, if we exceed the capacity, we could reallocate this array now, and when we go to print one array or the other, something's not, we're pointing at nothing, or we're pointing at dead memory, and in those cases our program could segfault and crash. None of this is good, and it's called the deep copy problem, and it happens whenever we're using dynamic memory in a class and we're not cleaning up our mess. We don't want to just copy pointers. We want to be copying what the pointers are pointing to. That's the solution to this problem. And here we are, the solution to the deep copy problem. And what is it? It's the big three. And the big three are the copy constructor, the overloaded assignment operator, and the destructor. And let's start with the copy constructor. What we have here is an initializer list, which is just copying over the number of elements in the capacity from the other inset we're passing in. And then we are allocating a new array for data. And we are just using the new keyword in C++, setting, we want it to be an integer array, and we're passing it the size, which is going to be the capacity of the other array we are passing in. The other thing we want to do, obviously, is we want to copy the data from other to the new. And for that, I just have a very simple for loop, which is taking the data from other and assigning it into data. And one thing you might be wondering is, when would this be useful? Well, it could be useful when you explicitly call it like this, int set, and then you could pass it an inset you already have. Or another subtler case where it would be useful is, let's say you have a function called doThing, and it takes in an inset, and we want to call it with some inset, but we want to be creating a copy. Well, remember every time C++ functions are called, they are creating a copy. If this wasn't here, the copy we would create would be a shallow copy, meaning, again, the problem we saw earlier where dynamically allocated resources are being shared among the two containers, which is bad. So even though we're not explicitly calling it here, C++ will make an implicit call on this line and call this function. All right, now let's talk about the overloaded assignment operator. And this is in the case where this would be used in the case where we are assigning the right-hand side into the left-hand side using the assignment operator. And first thing we do in this function is we're checking for self-assignment. RHS is just going to be the right-hand side that we're going to be assigning to the left-hand side. So the first thing we do is we do a quick check between this, the current object flowing through our class, and the right-hand, a reference to the right-hand side. And if they're the same, we know that they're the same, and there's no use in doing any sort of copying, so we return. The next thing we want to do is, if it's not the case that the right-hand side and the left-hand side are equal, is we want to delete the data, which is going to destroy the array. And then we just want to copy over all of the other parts, just the normal shallow parts of the shallow members, like the capacity, the number of elements. And then we want to create the new data array, which is going to be equal to, again, it's very similar to what we did in the copy constructor. We're allocating a new array of size capacity. from the right-hand side. So now we have this empty array, and we have to fill it with what's in the right-hand side. And again, we use a very simple for loop to just copy what's from the right-hand side into the new object, and we return star this, the dereferenced pointer, which is going to then return like the left-hand side, and we've made a deep copy there. And lastly, we have the destructor. The only purpose of the destructor is to deallocate the memory that we've initially allocated in our class. And this is called implicitly as the program is winding down, or as I think it's called whenever we're leaving the scope. And the really great thing now about having these three things is the programmer who's using this ADT no longer needs to worry about making deep copies themselves. They don't need to be aware of all of that the big three are implemented. I hope you guys enjoyed that. Thank you very much for watching, and have a nice day.